Questions 21 through 25 on the 2002 Grade 10 AMC 10B. Andy's lawn has twice as much area as Beth's lawn and 3 times as much area as Carlos's lawn. Carlos's lawnmower cuts half as fast as Beth's mower and 1/3 as fast as Andy's mower. If they all start to mow their lawns at the same time, who will finish first? So they have their lawns and they've given you a comparison in terms of the size. So the areas is what they've initially talked about. And they told you that Andy's lawn has twice as much area as Beth's lawn and 3 times as much area as Carlos's lawn. So if, say, Andy's lawn is 6, we can give it any unit you want, meters squared, then Beth's lawn would be 3 meters squared, and Carlos's lawn would be 2. Right? Andy's lawn is twice as big as Beth's and 3 times as big as Carlos. And then now they're talking about a lawnmower and its speed in terms of how much or how fast it cuts. Carlos's lawnmower cuts half as fast as Beth's and 1/3 as fast as Andy's mower. So similarly, if Carlos's lawnmower, let's say, is 2 in terms of its speed, meters squared per hour, whatever unit you want to use, then Beth's would be 4 meters squared per hour, and Andy's would cut at 6 meters squared per hour. So Andy, Beth, and Carlos, right? Carlos's lawnmower cuts half as fast as Beth's and 1/3 as fast as Andy's. So now they want you to figure out, if they all start to mow their lawns at the same time, who will finish first? So we have to compare the times. So let's start with Andy. He's going to cover 6 meters squared, and his lawnmower cuts at 6 meters squared per hour. So 6 over 6 is 1, and then the units become meters squared over 1, and invert and multiply, and you get hour over meters squared, and therefore this just becomes 1 hour. So it takes Andy 1 hour to cut his lawn. Let's turn our attention to Beth. Her time, she has 3 meters squared, and these are very small lawns, 3 meters squared. But that's okay, it doesn't matter, as long as we follow the question stem and its information. So her speed is 4 meters squared per hour, and therefore this is 3 over 4 hours. So it's about 45 minutes. And then finally, Carlos, his time is 2 meters squared over 2 meters squared per hour, and this looks like 1 hour. So Andy takes 1 hour, Carlos takes 1 hour, but Beth completes her lawn in 45 minutes. So Beth is the one who finishes first. So the answer for 21 is B. In triangle XOY, let it be a right angle triangle with the angle XOY is 90. Let M and N be the midpoints of OX and OY, respectively, given that XN is 19 and YM is 22. Find XY. Okay, so a diagram is most definitely needed. Here we go. Here's a nice right angle triangle, and we have to label it X, O, Y, and angle XOY is 90 degrees, so this one is 90 degrees. Let M and N be the midpoints of OX and OY respectively. So M will be approximately here, it's the midpoint, and N will be approximately here, it is the midpoint of OY. And they are giving us some distances, so we'll have to draw in some lines from X all the way till N, and Y all the way till M. And they've told us that XN is 19 and ym is 22. Find xy. Okay, so they want us to find that length right there. All right, so let's start labeling some things. O to y, this whole distance, we don't know. But we know that n is the midpoint. So if ON is A, NY will also be A. Correct? Because the midpoint obviously cuts that line in half. And in a very similar way, XO, we don't know the distance, but we know that M is the midpoint. So if O to M is B, M to X will also be B, because M cuts that line XO into half. And then now, we've got a whole bunch of relationships involving the Pythagorean theorem. So the first triangle I'm going to look at is this one, XON, that one. And that one will give me the following Pythagorean relationship. The base is A squared plus 2B squared is equal to 19 squared. Correct? So this is A squared plus 4B squared is equal to 19 squared, like that. And that's pretty much as far as we can get. Now let's look at another triangle and we'll figure out another Pythagorean relationship. This one right here, MOY, that one. That one we can get another similar equation, B squared plus 2A squared is equal to 22 squared. So this becomes B squared plus 4A squared is equal to 22 squared. Correct? So now we can use these two equations to isolate for one, and we should be able to solve for A and B. And then once we have A and B, we can use the full triangle to find XY right there. So what do we want to do here? Get rid of some variable, right? So we can do that any way you want. It's really up to you, whatever you feel comfortable. There's several ways of going about it. I'll just do 4 times equation 1 minus equation 2. That will help me get rid of one of the variables. So 4 times equation 1 gives me 4A squared plus 16B squared minus equation 2, so minus B squared minus 4A squared. And then the other part of the equation on the right is 4 times 19 squared minus 22 squared. All right? So this gives me the 4A's and the minus 4A's, that's all gone. And this gives me 15B squared is equal to, if you multiply this all out, you get 1444 minus 22 squared, which is 484, like that. So 15B squared is equal to 960. So B squared is going to be 960 divided by 15, which is 64, and therefore B is equal to 8. So that worked out really well. And therefore we can solve for A. You can plug A back into any of those. A squared plus 2B squared is equal to 19 squared, like that. So A squared plus 16 squared is equal to 19 squared. So A squared equals 19 squared minus 16 squared. And this is 361 minus 256, A squared. A squared therefore is equal to 105. And therefore A, move this up a little bit, is the square root of 105. Okay? So then now we can easily figure out xy, because we have A and B. xy, I'll just write it here first because we have the diagram in front of us. Xy squared is equal to 2A squared plus 2B squared, like that. Okay? Xy squared, I gotta squeeze that in there. This whole length right here, that length, that hypotenuse basically. Xy squared is equal to 2A squared plus 2b all squared. Okay? So I'll write that over here. xy all squared is equal to 2a all squared plus 2b all squared, like that. So what do we have here? 4a squared plus 4b squared. And 4a squared, well, a squared is right here, 105. And for b squared is right here, 64. And therefore this looks like 4 times 105 plus 64. So that is equal to 169 times 4, which is 676, is xy squared. And if you take the square root of that, you will get 26. So xy is equal to 26. And therefore, number 22, the answer is B. Let AK be a sequence of integers such that A1 is equal to 1 and AM plus n is equal to AM plus AN plus MN for all positive integers m and n. Then a to the 12 is. Okay, so I think we have to go and figure this out one at a time. They give you the first one. So now let's figure out A2. A2 is essentially A1 plus 1. And therefore that would be A1 plus A1 plus 1 times 1. Correct? I'm just following this equation exactly the way they did it. So A1 is up here. It's 1 plus 1. And 1 times 1 is 1. So therefore A2 is equal to 3. I'll put that in there, A2. Now we move to A3. A3 is A2 plus 1. So using this formula, that would be A2 plus A1 plus 2 times 1, like that. A2 we figured out over here is 3. A1 is equal to 1 right there at the top. And 2 times 1 is 2. So this becomes 4 plus 2, which is 6. Now the good news here in this question is that instead of having to figure out A4, A5, A6, A7, A8, A9, A10, A11, A12, which is, quite time consuming, especially in a math contest, you can skip. You can go directly to A6. Because watch what happens. A6 is really just 3 plus 3, right? So that means that is equal to A3 plus A3 plus 3 times 3. Entirely based on our formula. I'm not doing anything other than the formula. So A3 we figured out up here was 6 plus 6 and plus 9. So therefore A6 is equal to 6 plus 9, which is 12 plus 9, which is 21. And now we can get to our A12, which is what they want us to figure out up here. A12 is going to be A6 plus 6, which is A6 plus A6 plus 6 times 6, like that. A6 we figured out was 21. So 21 plus 21 plus 36. And this is 42 plus 36, which is 78. And that is A12. So the answer is 78, and therefore 23 is D. Riders on a Ferris wheel travel in a circle in a vertical plane. A particular wheel has a radius 20 feet and revolves at the constant rate of 1 revolution per minute. How many seconds does it take a rider to travel from the bottom of the wheel to a point 10 vertical feet above the bottom? So I have drawn a Ferris wheel in green, and I've represented the bottom of the ground by that black line. And now I'm going to draw the radius, and I'm going to draw where the rider is on the Ferris wheel. So this is a line representing the radius. So if that's the center of the wheel, that orange line represents the radius, and this red dot is where he is, the rider. He is, according to the question, 10 feet above the bottom. So his distance from the bottom to where he is 10 feet. So I'll label that in 10. So if that is 10, this is 10, and this is 10, and that is the radius, which is 20, according to the question. And then one final line from the center of the circle to where he is, and that should complete our illustration, and that's a right angle. Okay? And then the radius is 20, so that line that I drew is 20. So in this triangle, we can now calculate this part, that distance right there. And that will be using Pythagoras, x like that. So we have 10 squared plus x squared is equal to 20 squared. So this is 100 plus x squared is equal to 400, and therefore x squared is equal to 300, and therefore x is equal to the root of 300, which looks like 100 times 3 under the square root sign, so this becomes 10 root 3. So x is equal to 10 root 3. Okay? Now, I hope that you can figure out a relationship between the angles in that triangle. But if you can't, it's okay. I will draw it out for you here. That triangle is a triangle that looks like this, correct? And it has one right angle right here. And we know that this side is 10, this side is 20, and we calculated that this side here on the bottom is 10 root 3. Now, if you have a triangle that has 60, 30, and 90 as its degrees, it has a certain ratio in terms of its sides. 2, 1, and root 3. I see the same thing in this triangle in terms of its ratio. Right? The ratio 1, 2, and root 3. So this is a 30, 60, 90 triangle. This is 30 degrees. This is 60 degrees. Okay? So this angle right here is 60 degrees. And therefore, when he is going from the bottom right there till that red dot, he has to travel 60 degrees in terms of the radius and the circle. Correct? Because he's going from the bottom of the wheel to a point 10 vertical feet above the bottom. So here's the bottom of the wheel right there, and he's going from that point till this red dot. And to do that, this radius has to essentially swing 60 degrees. All right? So that is when we look at this part of the question. This wheel revolves at a constant rate of 1 revolution per minute. So what that means is that it goes all the way around in 1 minute. So it goes 360 degrees all the way around in 1 minute, which is 60 seconds. So we want to know how much time will it go in 60 degrees. So if this radius is now swinging from here to here, it's basically traveled 60 degrees. How much time? We'll call t for time. And that's our mathematical equation. So just solve 360t is equal to 60 times 60, like that. And therefore 60 times 60 is 3,600 is equal to 360t, and therefore t will be 3,600 divided by 360, which is 10 seconds is how much time it takes for him to get to that position. So the answer to number 24 is D. When 15 is appended to a list of integers, the mean is increased by 2. When 1 is appended to the enlarged list, the mean of the enlarged list is decreased by 1. How many integers were in the original list? So we've got a list of integers, a plus b plus c dot dot dot. We don't know how many there are. And if you take their mean, divide by the number, so I'll let the number be n, we're going to get a certain number. I'll call it m representing the mean. So now let's work with the information they gave us in the question. They're first saying that you take this list and you add to it 15. And if you do that, the mean increases by 2. Now, what is our new number of integers? It's n plus 1, because we've added one number. Then they say, when you take this enlarged list and you add to it 1, so you're taking this enlarged list and you're adding to it 1, then that mean decreases by 1. So it was m plus 2, so now it will decrease by 1, becoming m plus 1. And then how many integers do we have to divide by? It's n plus 2. All right? So these are the two equations that we will need to work with. So the first one becomes a plus b plus c dot 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 15 over n plus 1 is equal to m plus 2, right? And the second one is a plus b plus c dot 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 plus 16 is equal to n plus 2 is equal to m plus 1, like that. So these are our two equations that we have to work with, and we got these two equations based entirely on the information in the question stem. All right, so let's work with those. What can we do? Well, we can subtract one from the other, and that hopefully will allow us to eliminate at least one variable, or not. We'll see. There is really not much we can do, so because we have so many variables, we have a, b, c, and all that stuff. But if we can get rid of all of those, that's really going to help us. All right? So let's do that. But before I do that, I want to try to simplify this, because we have so many variables, it's going to get very confusing. Let's go back to the original one, and you'll see something very interesting happens. A plus b plus c dot 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 equals nm, right? I just cross multiplied. So instead of writing a plus b plus dot 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 and all that stuff, we can just put nm. So the first one really just becomes nm plus 15 over n plus 1. See what I did there? Instead of putting a plus b plus c, blah, 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 I just put nm. And that equals m plus 2. So this is our first equation. And then our second equation simplifies to just nm plus 16 all over n plus 2 is equal to m plus 1. So you see how that's much more cleaner. And now I can proceed with what I wanted to do originally, and it will be much better because we now only have two variables, n and m. So 1 minus 2, nm plus 15 over n plus 1 minus nm plus 16 over n plus 2 is equal to m plus 2 minus m minus 1. All right? So a lot of algebra here. So let's just do the right side. That seems to be the simpler one. That just becomes 1. And on the left side, we have to get a common denominator. So multiply top and bottom here by n plus 2 and n plus 15. And this other side, we have to multiply top and bottom by n plus 1, like that. and that will be all over n plus 1 times n plus 2. Okay, so far hopefully you're with me. So let's multiply this all out. We have n squared m plus 15n plus 2nm plus 30 minus n squared m minus nm minus 16n minus 16. And I'll just cross multiply. It equals 1, but I'm going to cross multiply that with that. And I'll expand it too. Why not? N squared plus 2n plus n plus 2. All right, just basic algebra here. No, nothing fancy. Hopefully things will start to cancel. This guy goes. Anything else that goes? Well, let's see. Let's start combining. 15n minus 16n gives you minus n. 2nm and minus nm gives you just nm. 30 minus 16 is 14. And then this side is n squared plus 3n plus 2. So hopefully no mistakes. Hopefully we're good so far. Let's put everything on one side. N squared. Bring the minus n over, and that becomes 4n minus nm, and 2 minus 14 is minus 12. Equals 0. Okay, what can we do now? I guess we can factor out an n. That'll give me n plus 4 minus m, and I'll bring the 12 over. And that's about as far as I can go. Okay, so how do you solve this? Well, because you have two variables, we have to use something called inspection. All right, so inspection basically means you have to plug in some numbers and see what happens. Well, 12 is what this all equals, and therefore n has to divide 12, right? Something times something is equal to 12. So 12 divided by n must be an integer, because what is n? N represents the number of integers, and m represents their mean. So for example, just want to make sure, it's a list of integers, correct? And the mean is increased by 2, blah, blah, blah. But n is the number of integers. So n has to be an integer itself. So for example, if there's 15 integers, 20 integers, n is always going to be an integer. So what integers divide into 12? Well, let's see. How about 12? That divides into 12. So let's put n as 12 and let's see what we get. All right, if n is 12, then that means 12 is equal to 12 times 12 plus 4 minus m. So that means 1 is equal to 16 minus m, and therefore m is equal to 15. Okay, so now we've got n equal to 12 and m equal to 15. Is this right? Well, we have to verify it. We have to go back and verify it by plugging it into our equations, which were right here, these guys. These were our two initial equations, and we have to use those to verify our values of n and m. If they satisfy this, then we're good to go. All right? So we have to use those two. So I'll write them out over here so that they are ready for us. All right, let's go for it now. So let's use the first one here. First one and second one. Let's try to verify with the first one. nm plus 15, so that would be 12 times 15 plus 15 all over n plus 1, which is 13. This gives me 180 plus 15 all over 13, and that is equal to 195 over 13, which is 15. All right? Now the other part of it is m plus 2. M plus 2 is 17. So unfortunately, 15 does not equal 17. So this is a dud. We can't go with that. That's okay. That's what trial and error is all about. So n can't be 12. Let's go with the next one. What else can n be? Well, what else is 12 divisible by? It's divisible by 6. So let's go with that. N is equal to 6. And therefore, 12 would be 6 plus 4 minus m. So 2 would be equal to 10 minus m. So m would be equal to 8. So we got 6 and 8. All right? So let's use that number 1 to see if we are correct. nm, so we got 6 times 8 plus 15 all over n plus 1, which is 7. 6 times 8 is 48 plus 15 all over 7. So this is 63 over 7, which is 9. And that has to equal m plus 2. And m is 8 plus 2 is 10. So 9 does not equal 10, so that's a dud. All right, let's keep going. It can't be 12, it can't be 6. What else is 12 divisible by? It's divisible by 4, so let's let n equal 4. If n equals 4, we've got 12 is equal to 4. 4 plus 4 minus m. So this becomes 3, this becomes 8 minus m, and therefore m is equal to 5. N is 4 and m is 5. Let's see if we can do it right here. N is 4, m is 5. All right, so the first one would become nm, which is 20, plus 15, all over n plus 1, which is 5. This is 35 divided by 5, which is 7. And we want it to equal m plus 2, which would be 5 plus 2, which is 7. Great. So we verified that one. Now we got to verify number 2. nm plus 16, so 20 plus 16, all over n plus 2, which is 4 plus 2, which is 6. So we got 36 over 6, which is 6. And that has to equal m plus 1. m plus 1, m is 5. 5 plus 1 is 6. Perfect. So 6 is equal to 6. We have verified both of them. So the correct answer is n is 4 and m is 5. N represents the number of integers, I believe. Yeah, how many integers were in the original list? N is 4. So 25 is A.